Capillary tube in refrigeration system. 1. Introduction to capillary tubes. Welcome back to HVAC official channel. Today, we are going to discuss one of the simplest yet most important components of a refrigeration system, the capillary tube. A capillary tube is a fixed orifice metering device made of a long, thin copper tube with a very small internal diameter. Unlike expansion valves, it has no moving parts, which makes its construction simple and reliable. The primary function of a capillary tube is to create a pressure difference between the high-pressure side, condenser, and the low-pressure side, evaporator. In simple words, it controls the flow of refrigerant and ensures that the system operates at the correct pressure for efficient cooling. Because of this role, the capillary tube is often called the gatekeeper of the refrigeration system. 2. Working principle and mechanics of a capillary tube. The working principle of a capillary tube is based on frictional resistance and pressure drop. When high-pressure liquid refrigerant coming from the condenser enters the capillary tube, it faces strong resistance due to the tube's small diameter and long length. As the refrigerant moves through the tube, its pressure gradually drops. Because of this pressure drop, a part of the liquid refrigerant starts to flash into vapor. By the time the refrigerant exits the capillary tube and enters the evaporator, it becomes a low-pressure, low-temperature mixture of liquid and vapor, which is ready to absorb heat from the surrounding air. This simple process allows the refrigeration cycle to function without any mechanical control device. 3. Function of capillary tubes in refrigeration systems. In a standard refrigeration cycle, the capillary tube performs two very important functions. First, it regulates the quantity of refrigerant entering the evaporator. Since the evaporator must receive only a specific amount of refrigerant, the capillary tube ensures controlled flow. Second, it maintains the pressure difference between the high-pressure side and the low-pressure side while the compressor is running. One unique advantage of a capillary tube system is that when the compressor stops, the pressures on both sides of the system gradually equalize. This pressure equalization reduces the starting torque required by the compressor during restart, allowing the use of low starting torque and low-cost motors, especially in domestic refrigeration systems. 4. Understanding capillary tube sizing. Capillary tube sizing is the most critical aspect of its application. Because a capillary tube is a fixed metering device, it cannot adjust its flow according to load changes. The refrigerant flow rate depends entirely on the internal diameter of the tube, the total length of the tube. If the capillary tube is too long or its diameter is too small, the evaporator will receive less refrigerant, causing starving, low cooling capacity, and possible icing. On the other hand, if the tube is too short or its diameter is too large, excessive refrigerant will enter the evaporator, leading to flooding, which can seriously damage the compressor. To avoid these problems, manufacturers and engineers use capillary tube selection charts that match the tube length and diameter with the system's BTU capacity, refrigerant type, and operating conditions. 5. Applications and usage of capillary tubes. Capillary tubes are mainly used in small-capacity refrigeration systems where the cooling load remains nearly constant. Common applications include domestic refrigerators, deep freezers, water coolers, small window air conditioners. These systems are usually critically charged, meaning they require an exact amount of refrigerant to work correctly. Because capillary tubes are simple, low-cost, and reliable, they are widely used in household and light commercial refrigeration equipment. 6. Advantages and disadvantages of capillary tubes. The main advantages of capillary tubes include low cost, simple construction, and no moving parts, which means minimal mechanical wear. The pressure equalization feature also helps reduce compressor starting load. However, capillary tubes also have some limitations. Because the internal passage is extremely small, they are highly sensitive to moisture, dirt, or debris. Even a small blockage can completely stop refrigerant flow. Another disadvantage is that capillary tubes are not suitable for systems with varying load conditions, because they cannot adjust refrigerant flow like a thermostatic expansion valve, TXV. 7. Choosing the right capillary tube. When selecting or replacing a capillary tube, it is essential to consider the refrigerant type, such as R134A, R600A, or R22, along with the evaporating temperature and system capacity. Always cut the capillary tube using a proper capillary tube cutter instead of pliers, as crushing the tube can restrict refrigerant flow. The system must be thoroughly evacuated, and a new filter dryer should always be installed. Even a tiny amount of moisture can freeze inside the capillary tube and cause a complete system blockage. Key takeaway for HVAC technicians. For HVAC technicians, it is important to remember that a capillary tube system is a perfectly balanced system. Adding extra refrigerant without proper diagnosis can worsen performance instead of fixing the issue. Before charging refrigerant, always check for partial blockages, moisture contamination, and filter dryer condition. Understanding small components like the capillary tube makes a big difference in system efficiency, reliability, and compressor life.